All right, we're going to solve problems using scientific notation, which basically means we're going to learn how to multiply, divide, add, and subtract with numbers in scientific notation. Okay, so the first one we're going to do is multiplication, and we're going to look at how we'd multiply these two numbers. Well, there's two ways. You can either get them both in regular form or both in scientific notation. The first way, just in regular form, you convert this back to regular form. That's going to be standard form, would be just 1200. And you multiply it. Remember, when you have 4 decimal places in the problem, you have 4 decimal places in your answer. Or you can do it, make them both into scientific notation. Well, that in scientific notation is going to be 4 times 10 to the negative 4. Okay? And then you go ahead and multiply these two numbers, the number part of them together, and that's going to be 4.8. You can kind of do that in your head. Then you multiply the two powers of 10. And remember, it's kind of like n cubed minus n times n to the negative 4. Well, when have the same base written twice, we add the exponents. So 3 plus a negative 4 is negative 1. So we have 10 to the negative 1, 4.8. But to make it look like a regular number, back to that, we have to move it over one place to make it look smaller because it's a negative exponent. Okay, that's our answer there. Next one, we're going to be dividing. Okay, it's a real problem. It's a real life situation. In 1998, we recycled 335 million tons of trash. At that time, the population was about 270.5 million. So find the average amount that each person recycled. And that got a little scratched out. But anyway, so average, as you know, means to divide. Okay, they've already done the adding for us. So we can either divide the whole regular numbers like usual and cross out the zeros and then divide. We get 0.13. Or we can make them both into scientific notation. 35 million becomes 3.5 times 10 to the 7th. This number becomes that. And then put the million on top of the 35 on top of the 27 number. And again, we have to divide these two like usual. You could probably do that on the calculator. And then remember, how do you divide exponents that are the same base? You simply subtract. 7 minus 8 is negative 1. So you have 1.3 times 10 to the negative 1. And now to make it look like a regular number, we convert it back because it's going to be a small number because the negative exponent, so move it over one place to make it smaller. So it's 0.13 tons. Okay, now we're going to add and subtract. To add numbers in scientific notation, you simply, there's really one good way to do it. You cannot, like this 1.34 times 10 to the 8th plus that number. Remember, you can't just add these two like you did when you multiplied, because these are not the same base. The same base, not the same exponent. It's kind of like 1.34 times n to the 8th plus 4.5 times n to the 6th. We never think, because those are not like terms. Okay? So you have to make sure that the tens have the same exponent, because that's when you can add them. All right, remember, you can only add like terms. Like terms have to have the same base raised to the same power. All right, so we need to make one of these guys look like the other one. It doesn't matter which one you did. I just chose to do the 10.8 to make it look like the 10 to the 6th power. 10 to the 8th power look like 10 to the 6th power. So what I realize is when I go from 8 to 6, I go smaller by 2. So to make it equal, like we talked about last time, you have to move this 2 decimal places over. I'm sorry, make it smaller. So I've got to make it larger. So you got to move this over 2 decimal places to make it look larger. So be careful with yourself because you can get confused. So you must have 2 decimal places, move the decimal 2 places to make it larger. So it's 134. So now I have 134 times 10 to the 6th. So I simply multiply, I add them together. Now I have 134 times that plus 4.5 times that. But make sure you line up the decimals. When you add the numbers, you line them up. It's 134.0 plus 4.5, and you get 138 times 10 to the 6th. But that number is not in scientific notation, because that's not between 1 and 10. So I have to move it over to make it smaller. I make it this smaller. I got to make the exponents bigger by 2 because I moved it over 2 places. Ends up being 1.385 times 10 to the 8th. So you might want to stop and rewind and make sure you go over that part, because that part at the end can be tricky, and we have to just make sure you balance it out. Okay, now we're going to subtract. Subtracting is very similar. You have to have the same power of 10. And so you can pick either one. Here I'm going to pick, let's make 5.1 times 10 to the negative 1. Let's make it be the larger one. So we want to get everybody to be 10 squared, because who likes to work with negative exponents, right? So again, you're thinking from negative 1 to 2, I'm going 3 places larger, right? I'm larger by 3, because negative 1 plus 3 will give me 2. So if I go larger by 3 with the exponent of 10, I've got to move my decimal place to make this number smaller so that they're equal. So I move it over 3 places to make it smaller. So it's 0.0051 times 10 squared. Now I can add them, because now I have my two same power, same base raised to the same power. So I have like terms. So I subtract them, and this all got scratched out, but you can see, or you can just do it on your own. And minus, make sure you line up the decimals, okay? Then you subtract, and you get that number, which already is between 1 and 10, and it's times 10 squared, because that's what I landed on when I decided which one I was going to do, okay? Okay, last one. We only have 5 in this one. Okay, let's go review a little bit. Okay, so national debt is 7 trillion, and there are about 300 million people in America. How much could each person pay if we could just all pay a certain amount and eliminate the debt? Wouldn't that be wonderful? Well, let's see how much that would be. We have 7 trillion, we have 300 million. Okay, that's how those numbers really look, like how big that trillion is. So we make them into scientific notation. So it's 7 times 10 to the 12th, because you had to move it over 12 decimal places. And for the 300 million, we had to move it over 8, so it's 10 to the 8th. We can divide 7 divided by 3 is about 2.3. Okay, and 7 times, and then this now we just simply subtract. So 12 minus 8 is 4. So everybody needs to pay 2.3 times 10 to the 4th. Well, you're probably wondering, how much money is that? Well, again, let's go ahead and make it into a standard number. And because this is a high number, this is a positive, we need to move it to make this number positive. We move it 4 places. So it becomes 23,000. If everybody could just chip in 23,000, every American, children and everybody, you guys too, could pay $23,000, we'd be rid of our debt. It's a lot of money. Okay, number 2, the average American eats 80 pounds of vegetables, especially preteens. If there are 300 million every year. If there are 300 million Americans, find the total veggie consumption. All right, so total, you know, is a number we either usually add or multiply. Would be even faster adding. So in this case, we're going to multiply. So 80, you make it in a scientific notation, is 8 times 10 to the first power. 300 million, we already did up there. And now we're going to multiply. So we have to multiply 8 times 10 to the first times 3 times 10 to the 8th. Well, I don't need the same powers, right, because I'm multiplying. So it's 8 times 3 is 24. And just like 10 to the first times 10 to the 8th, we add the exponent, so it's 10 to the 9th. So that's not in scientific notation yet. So to make it in scientific notation, we make this a little smaller. So we go up 1 for this one. So it's 2.4 times 10 to the 10th pounds of vegetables that we consumed, which is a lot of vegetables. Somewhere up in the billions, I guess, because 8 and 12 are millions and trillions. Anyway, we'll talk